Actually, while I write these, you tell me, what the hell do you remember from Calvin yesterday? What's a binomial? What do we call it that? 5 sets of 2. Binomials like 2 numbers. Awesome. Does this symbol look familiar to you guys? Yeah? Liquid notation? What? Sigma notation. Sigma notation is where it's like a sum. You add them up together, yeah? Yeah. Yeah. Yeah.
Minus k.
Yes.
1 to the power of minus k.
Yeah.
And then to the power of k.
Beautiful. Awesome. Now, do you guys see the 1 there? It's 8 minus k, but really, 1 to 8 minus k, but really that's just 1. So when I write it again, like where I need to use it, I want to avoid the 1 because I don't really need it here. Same thing here. Let's go. Do you know, can you write sigma notation for this first one? How many brackets? 3 of them. What goes in that first bracket?
Wait, which one is it?
Let's do this first.
5, choose K.
5, choose K. Beautiful. And then it's just 1. But do we care about the 1? Not really. So just because I can see in hindsight, it is 3 brackets, but the 1's kind of useless. So I'm going to just write my X, right? Or, I just want completion. Put it here. And what are my powers, Janelle?
5 minus K.
K. Good. Next one is going to be 3, choose K. 1, 3 minus K. X, K. So far, so good. Just yesterday's stuff. Okay. Now, in a question in the exam, they usually won't give you part A and B. That was just for me to help you jog your memory. Part C is what they'll just give you straight from the bat. Okay. So this is just to help you jog your memory. But imagine we're just starting this from scratch. Let me show you exactly what I would write in an exam. Okay. I can see that they want me to show these coefficients are equal. Like 8 choose 3 equals these guys. What I always want you to do is start with the simple side. That would be this side, right? It's 8 choose 3. This gives you information. 8 choose 3 tells you, or actually looking back at this one, 3 choose K. Think about where those came from in terms of this. And you'd be able to figure out what 8 choose 3 means. Yeah? 8 here, it means how many brackets you have. So the expansion I'm looking for, what do you think is the power? Which is 8. 1 plus x to the power of 8 will get you coefficients with 8 in there. Sounds good? Okay. Now, look carefully over here real quick. This term is actually 3 choose k, x to the k. In other words, whatever's on the bottom of that binomial, do you see it just matches the power you want? So from here, I can see that 8 tells me 1 plus x to the power of 8. What does the 3 actually tell me? What does that 3 represent? X gives me a power of x, doesn't it? This is x to the power of 3. Does everyone understand that? So just from this simple side, you can see 2 things. 1 plus x to the 8, x cubed. In your response, this is what you're going to write first. Consider the coefficients of 1 plus x to the power of 8. This is your first initial statement. Now you're going to look at the coefficients of, can you guys fix this up? 1 plus x to the power of 8. You're going to look at the coefficients of this in 2 different ways. The first one is the easy way, which is straight up just like, what is 1 plus x to the 8, okay? Now, also, I think I just had food, so I've got a huge food coma brain right now. I made a little mistake. I don't want to write that. It's coefficient of an x term. Like, what does it mean to find the coefficient of the whole expansion? So, I actually wanted x cubed. Does that make sense? Sorry, can you fix that up for me? Okay, so from 2 different things. First one, 1 plus x to the power of 8. Alright, 1 here, because this is the first way I'm going to consider the coefficient. Next step, every time you see expansion, what's the first thing you're going to write? Something else. Summation. So you're going to write sum of 8 choose k, 1 to the power of something, x to the power of k. So I'm okay if you just write up to that step without the 1. Now, for completion, you should really put what values are here, because this tells you what value of k you should start from and what value of k you should end at. When Calvin did it yesterday, he didn't do that many times. That's totally fine. It just depends on how much detail the teachers want. Okay, so it's kind of school dependent. For this one question, I'll do it first. Does anyone know what value of k I should start with? 0. I want to start from 0 because I know 8 choose 0, x to the 0 would give me that first term, which is usually a constant. Okay. I'm looking for my x cubed within this whole big expansion. But this would be like a bunch of terms added together. Fair enough. What would be on top here? Where would we stop?
8.
8. That's the maximum number of things I can get. So from 8 brackets, you think I can get 0 things or I can get all 8 things. Obviously can't get 9. So that's for completeness. At Bureau, they want you to write that as well. Yeah, make sure you put the red thing. Okay. Now from here, do you guys see I can actually look at the coefficient of x cubed? What value of k do I want for x cubed? 3. So what's the coefficient? It's just h choose 3, which matches that. Sounds good? So I want you to draw an arrow to represent coefficient, and it's okay to just do this. You just go, therefore the coefficient is h choose 3. And that's fine, because you've already shown that. This is the thing I'm looking at. Alright, now step 2. I'm going to look at the coefficient from another expansion, or another representation of 1 plus x to the 8. Now, 1 plus x to the 8 can be written in many different ways. For example, do you guys read this as actually just 1 plus x times 1 plus x to the 7? So I can split it up in any way I want, right? The way to see how you want to split it up is you look at the right-hand side. What do you guys mean? Look at that first pair. Which one of these numbers tell me about the power? Is it the bottom one or the top one? The top one. So what do you think I should split this up as? 5 and 3. I usually like to write the smaller one first, and then the bigger one, because actually when you do the bigger one first, you kind of run out of powers eventually. Like, the big one's always going to have more than the small one. So I just write the small one and the big one. You should always make sure these two is actually equal to that. Sounds good so far? Alright, now, every time I see this, I write sigma. So I'm going to rewrite this in sigma notation. Vincent, help me out. What do I write for this one?
3 choose k.
Yeah.
1.
Yeah.
Which is just 1.
Which is just 1.
X to the power of k.
Awesome. Times. Now, something that I didn't do up there, which is a little bit incorrect, the next one, I'm going to write it with a different letter. And the reason I want a different letter is literally because they're different expansions, right? If I let this be k, like k equals 3, for example, then that forced me to make this also k equals 3, if I chose the same letter. So a different letter would be ideal here. We okay so far? Awesome. Now you would have done a similar question like this yesterday, but essentially, can you imagine, there are some powers of x from here, and some powers of x from here, that when I put them together, I get what I want. Now remind me again, what's the power of x I want? What did I tell the marker I'm trying to look for?
3.
X cubed, right? So I need to look for all the possible ways that this actually expands to x cubed. So remember, this has every single power from 1, like constant term, x to the 0, all the way up to x cubed. And this one has everything from constant term all the way up to x5. So we're looking for all the pairs that work, right? Start from the smallest possible thing. Imagine a constant term here. I'm going to call it x to the 0. That's what it's represented by, because there's no x term. What value of x would you pick from this bracket to make it x cubed? X cubed, obviously. Great. Now, cycle through again. Go up one more power. Now I'm taking an x term from here. If I want an x term from this bracket, I should be looking for the x squared term to get x cubed. And then if I'm getting the x squared bracket from here, or the x squared term, then what would be the x power I want for this one?
1.
What's the last one? Awesome. You can see there's a lot. I want you to have a strategy to see whether you've gotten all of it. One strategy is you just look at the lowest one, and you probably should have exhausted all of it. Yeah? That's not always the case though. So here's a better way. Anyone got a better way? Guys, this is a show question. It's a prove question. Those are usually a bit harder, but the good thing is they actually give you the answer, right? Just look at the question, see how many terms there are. Now I put ... but in your paper, is it 5 of them? 4? 4. So you literally look at the question you want, and you go, okay, I had 4 pairs. That's where each of those pairs come from. Does that make sense, guys? Okay, ready? The next thing I'm about to do is not actually a full-on expansion. Because can you imagine expanding the x0 and x cubed term from here? It would actually leave me with an actual x cubed, right? All I'm gonna write is the coefficient of that, and that's why I have these arrows, because my marker can see, oh yeah, whenever he's drawing an arrow, it's just a coefficient. And I told them that I'm just looking for the coefficient. So I'm just trying to save a little bit of a few extra seconds to write x cubed, okay? All right, so I want the x0 term from that first bracket, that's the x0 term from here. Can you see that means k equals 0? Free choose 0 is that term, free choose 0, x to the power 0. Then I want the x cubed term from this guy. Can you see by writing in summation, all of them look like this? If I want cubed, I want j equals 3. And that means I want 5 choose 3. That's it. How are we feeling about that so far? These guys, they're multiplied. I'm going to write them a bit closer so they look more multiplied. Okay, so just to reiterate, this is 3 choose 0 constant term times 5 choose 0 x cubed. Obviously this is an x cubed term. I'm just leaving off the x cubed here because I'm just looking for coefficient. Let's go again. Jinan, what do I want for this guy?
3 choose 1.
Yep.
And then 5 choose 2.
Good. And I'll go on and so on again, right? Todd, what do I want for this one?
Choose
2. Yeah. Amy, what do I want for the last one? Try again. So I've got x cubed. Yeah. You just can't do it yet, but you're about to be able to do it. This is x to the power 3, so what's about k?
3.
Yeah. So what do I want the coefficient to be? Yeah. So 3 choose 3. Beautiful. And then this one is 0, so I want it from this term. What's the value of j? And then what coefficient do I want? Do you guys understand what I did there? Now, I found many different ways, 4 ways, to find x cubed. These are all different ways to get x cubed. When I have an expansion like x plus 2, x plus 3, you probably did this in your sleep, but when you first did it, you saw that, oh, there is multiple ways to get an x term, namely 3 times x or 2 times x. And then you do all your stuff, x squared plus 6, but in the middle it's like, okay, the 2 different ways I got the x terms, I should add them together, add the coefficients. So what do you think I should do here? I should add them. So this isn't actually the coefficient yet. When I say I'm looking for the coefficient x cubed from these brackets, the actual coefficient I want is the sum of all of these ones. Is that okay? You don't have to write that, but I'm gonna, I don't have to kind of conclude that here. I'm gonna do it up here in like one concluding statement, and you'll see how I tie all of that together. Let me give myself a little bit extra room. So here's what I say. Since 1 plus x to the power of 8 equals 1 plus x cubed, 1 plus x 5. Okay, let's fact check that. Is that true? That's true, right? I'm using this fact to leverage that whatever coefficient I look for from x cubed from this, it should equal the coefficient of this one, because they're literally the same expansions. Since this is true, the coefficients of x cubed must be equal. Their coefficients. So because their coefficients are equal, and I told them what each coefficient was from each side, I'm going to say, all right, 1 plus x to the a, I found it to be a choose 3. That coefficient must be equal the coefficient of x cubed that I got from there. What was it again? I showed them that it's the sum of all of these. So this must be equal these two. Okay. On a scale of 1 to 5, was that like 1 really hard? 5, I've got it. How do we feel? Yeah? Cool. You guys feel good? You guys have done it before? Okay, now, what was very interesting was for the people who haven't done this before, you found it really hard. Do you remember what Calvin told you? He ranked his topics, right? He said binomial out of every topic from year 11 to year 12 was like top 3 hardest. Good memory. It is top 3 hardest. And he's not lying, it is really hard. I would have got this question, in fact, I remember, I got this question wrong in year 11 because my teacher never taught me this as a technique. I just went into exam and I saw it, I was like, huh? How am I meant to come out of that myself? It's hard, right? There are some things in maths that you either know it or you don't. Do you remember in advanced there was a lot of stuff we could just figure out? It's like, oh, once I knew gradient function, I could then apply it to everything. There are some things which literally take up a whole page of working. You're not going to be able to dream up of this. So you need someone to show you. I'm just showing you how to do it. Then your favorite, the best thing you want to celebrate in maths is when the thing that I've just shown you is actually a technique that just works on every single question. This structure I've given you works for every single one of these questions. I promise you. So what I'm going to do today is I want to get us to recreate this structure. And then I'm just going to leave it blank and I'm going to do every single question with the same technique. That's all I'm going to do. And you'll see that it just all works. I would actually usually just prop this out and I do the next question, but I want you to try one. So I want you to help me recreate all the steps I did first, and then you're just going to try it with yourself. Sounds good? Okay. Try not to look at that. Try not to look at that. The actual question they want you to prove is, actually, Ed, can you read it to me? Now, I've actually got it, and you guys might be able to come up with this actually. Like, you don't have to look at the question, you know what it should be. 3 choose 3. Can you guys see where this comes from? What does the 1 and 3 remind you of? They add up to 4. Because remember this is like x to the 1 times x cubed, yeah? Do you guys see where the 6 and 3 came from? It's become 9, yeah? So my brackets always got split up as 6 and 3. Obviously in the exam, like this is not something you're trying to do on the spot, but it just shows you how repeatable our process is. My next one will be 2 and 2. Can you confirm that, Amy? Yeah, there you go. And then my next one's going to be 3 and 1. Nice. I'm going to stop there. You'll notice it's missing a few terms. What we got? Okay, now let's recreate the same set of working out you're going to use for every single question. Every single question. We'll try not to look at that, but like, kind of, it's on the board. From here, you're always looking for the coefficient of an x power. Which one do you look at to figure out what x power is? Which term? Start with a simple one, right? The 4. Good. The 4 tells you what power of x. So consider the coefficient of x to the power of, I'm going to leave this blank for now, and then you can make a note that this comes from looking at the k term in the simple n choose k term. So there is an n choose k that is obviously simpler than the other ones. You just look at that and they'll tell you what power of x to look for. Now this is like a kind of cliffhanger sentence. I'm saying, hey, I want to look for the coefficient of x from what? From 2 different things. So you're going to set it up so that the first one that you look for is the most simple one you can think of. And it would always look like 1 plus x to the power of something, okay? Again, I'll let you figure out what that something is, but it would come from the simple side again. When I say simple, it's like the lonely term, the one that's by itself. Okay, next, you write this as sigma notation. I always want you to show that working. And once you've done that, you can justify to the teacher why you can just say that. It's because literally all of them have this structure. So you'll tell me what that should be. Okay, step 2. Here's where you write the coefficient. Step 2 is your 1 plus x, 1 plus x. Remember, we're trying to equate coefficients, so we've got the simple version. Then we're going to split it into 2 brackets. So you guys figure out how to split it. Read the question here to figure out how to split it, okay? Write your sigmas. And then you do your little pairings. And then at the end, you finish with the same conclusion, but we can do that in a little bit. Alrighty. How do we feel about trying that ourselves? You think you got it? Give it a go. I'm going to walk around and help you. Amy, what did you put here? 9. So that came from this here. That one. Very good. And then you guys would have written your sigma notation. So I'm just going to write it for you if that's okay. 9 choose k, x to the k. And then you saw that the coefficient was 9 choose. Oh, I skipped this bit. What coefficient of x are we looking for? Clearly 4. That's going to come from here. Are we okay with that? 4. 9 choose 4. Do you guys get what I mean by like every question is the same? It's just this structure. Okay, now over here, I need to split 9 up. What tells you how to split it up? Vincent, you want to help me out with that?
It's 6 and 3.
I can see that this tells me how to split it. Remember, the top number gives me the powers. So 6 and 3. Now, Shabana, do you remember which one I told you to write first? Yeah, write the smallest one first, and later I'll show you what happens when you don't write the smallest one first. Some of you guys ran into that error, and I'm so happy you did, because that means you'll never make that again. But let's write the smallest one first. So I'm going to write 3, and then I'm going to write 6, okay? Then I'll write your sigma notation. 3 choose k, x to the k. Sudi, what letter do I use for this second sigma notation? Should I still use k?
I think you do another one.
I should use, yeah, any one, your favorite letter. But I should just use a different one. Yeah, that's wrong, isn't it? 6. Sounds good? Okay, you guys are working ahead in a different question, right? All good, all good. Sorry. I thought you guys were on the same one. All right, cool. Now, I do my pairings. Todd, you want to help me with my pairings? Times x cubed. Now, I'm just wary with starting with 1 because I might have, I didn't write the question correctly, didn't I? Yeah, I said it was intentional, and then I forgot my intention. So I didn't finish writing the whole question because I wanted to let you know, like, you could see what I should have left. And then, like, what I should have left is my last way to get 4, which was 6 choose 0, 3 choose, 6 choose 4, 3 choose 0. But anyways, other than that, in general, Todd, I want you to start from the lowest possible power, which is going to be 0. And the reason that works is because I write the smallest one here. But you'll see it doesn't work if I swap it around. Can you give me all the other pairings? X, 1, go up. Yes, sorry, that would be 4. Thank you, Liz. And then x, 2. Good. All right. Some of you guys fell for this, didn't you? I went around and saw. If you write x4, x to the 0, you realize something doesn't work in a second. Let's start with that one, actually. Remember we draw an arrow? x4, x to the 0. You're looking for an x to the 4 power. So what would the value of k want to be? 4. Can I get 4 from 3 objects? 3, choose 4. No, I only have 3 things to choose from. So do you see that automatically kind of, you know that's wrong? So you need to know why that's wrong, and you need to know to just avoid that when you get to it. But the good thing of writing small first and then big is that this will pop up as the last scenario. It kind of feels really bad when you write, if I wrote 6 here and then 4, this is the bad case. 1 plus x, 6. 1 plus x, 3. And the first thing I did was like, oh, let me just get x to the 0 and I'll get my x to the 4 term. Do you see you start off with a bad one? And then you kind of have like a sour taste a little question. You go like, oh, it's exam, I'm stressed, I'm going to skip this question, I don't get it. Like you might go into that. In fact, that happened a little bit, right? Like you kind of threw off a little bit of your question. Like, oh, it doesn't work anymore. So do you guys see starting with the bigger one will get you, and then you start with x to the 0, you might run the risk of not having enough powers from your second bracket to actually match the bigger power, okay? All right, cool. I'm glad we fell into that trap. So I'm gonna cross that out because I don't want it. In general, you would probably just think about it in your brain and avoid it. And then my blue arrow represents all of my coefficients. So this would be, I'm gonna do this real quick. 3 choose 0, 6 choose 4. Are we okay with that? I'm gonna do it silently and you just check in your own head if it's okay. Usually I do that to like test you on purpose, but that one I generally just made a mistake. And I'm just gonna write the fake one. 3 choose 4, 6 choose 1. Can you see how that cursed that looks? I can't do that one. That is why I don't want that last one. Fair enough? Okay, I'm gonna need a little bit of board space here. So
under all of this is your conclusion. The conclusion is the fact that you consider two things that are equal, right? What were the two things that were equal? The power 9 one and the split up one. Do we agree with that? So you write this. And then you say we are now allowed to make what equal? These two are equal, so the thing we're looking at, the coefficient. So you could say like we can make the coefficient equal, the coefficient must be equal. You could say, since this is true, we can equate the coefficients. That's another fancy way of saying it. That's why it's called equating coefficients. We can equate the coefficients of x4. And that's where that came from, right? Hence, since they're equal, you write the big thing. 9 choose 4 equals 3 choose 0. And please write more than just 1, but I ran out of space. So plus a few, 3 choose 3. I am writing the wrong one. What am I writing the wrong one? Is this the right one? Oh, okay. Now, as a teacher, and I am a teacher, I would mark this correct because in HSC and in general, math should be marked based on understanding. This shows me you understand everything, and this is just a real, like it's literally just, like we write x plus 1 and 1 plus x all the time, and they're the same thing. However, if you wrote this, like, just to be safe at school, because some schools mark weird, they shouldn't mark you wrong for this, just to make sure it's like in that order. Is that okay? Yeah. How do we feel about it? You know how we put votes before? Can you show me again? How do you feel about it now? Good. I'm glad at least there was at least one increase of finger because you saw it was the same thing and you just did it by yourself. Did I help you over there? Not really. You just kind of did it by yourself or with each other. Got it? Happy? Okay, now let's run through it really quickly. Are you okay if I rub off this part of the board? Yeah, or maybe I'll leave this one for now and I'll just rub off this one because you can see the workings the same. That's the beauty of this. All right, the question is now, I think it's example 3. Oh, Paragirls, did you get example 3? That's okay. No worries, no worries. Can I get you to help me do a little bit of this one? Because I was just going to talk through it anyway, but since you guys gave it a go already, I might get you guys to help me. I have confidence in you. Pahu has confidence in you. Okay, guys, look at the things I'm rubbing out. It is literally just the stuff that's like, you know, that you just have to rewrite again. But otherwise, the structure's all here. Fair enough, right? This structure is all the same, and so on and so on. Okay, the question. Was it n plus 1 choose something? Or, yeah, n plus 1 choose r equals n choose r plus n choose r minus 1? Is that what it says? Other way around?
No, it's r plus 1.
Oh, okay. And then r,
And then
r.
r plus 1. Plus 1.
Yeah, you're right. Cool beans. Okay. Now, I want you to look at something. There is a simple side, isn't it? But it looks way more simple this time. But that looks more simple, yeah? The scary side comes from splitting this up into a pair of brackets, and then you get a pair of binomials. I just want you to notice something that makes this question feel a bit more janky. Do you see any pairs there? So we'll do the question, and you'll see at the end why it looks like that, and then you realize it's not something to be scared about, okay? But typically you see pairs, this one's not, so it's a little bit different. Also, did you notice there are only 2 terms? That's good news. Why is that good news? When you look at this and there are 4 terms, that tells you 4 pairs, right? When there are only 2 terms, do you see there's just less work to do? So actually, don't be too scared of this one. Like, it's nice. It shouldn't take that much working. Okay, Paragirls. My step was you start from the simple side, and then you look for what x power you want, and then you look for what kind of big expansion you want, right? So let's start with this. What x power do I want based on this? Do you guys understand that? It's r plus 1 because this is the number of brackets, and this is what power I'm choosing from it, okay? So the first step is r plus 1 from the big bracket. What's the big expansion I want, Sudhi? Yeah. 1 plus x to the power of n plus 1. So I get that from here, because I know this must be, like literally if I get the coefficient of r plus 1 from this bracket right now, I get this. Cool. Okay, now I'll write our sigma notation. So n plus 1, choose k, x to the k. All right. The coefficient, guys, is literally just n plus 1, r plus 1. All right. Do you know, I kind of gave you the hard task. I gave you the easy one, didn't I? This is splitting this guy, right? You're meant to look at the right-hand side to figure out how to split it. Before we tell the class, we'll let them catch up a bit. Everyone just look and think about how you're going to split 1 plus x n plus 1 to get these terms. Have a think. I want n's. How the hell would you split this into two things? Yeah. Okay, Janelle, what do you think? N and 1. I think the n's very obvious. Can someone tell me why it's obvious? Where did I get the n from? This is meant to be a very obvious question. It's meant to be a boring question. We always get that from that side, right? Like the side with the pairs. In this case, there's no pairs. So that's where I get the n from. Did I have to think too hard about the 1? No, didn't they just come automatically? If there was a total of n plus 1, and I see I just want n, it's not telling me what the other number is, well, I'll just go, okay, I took n out. How many am I left? It's 1. Does that make sense? Yeah? Cool. Okay, now we write this in sigma notation, so I'll do that again for you. I'm going to use a different letter, so I'll call it J. You know what? Let's do it like this. Okay, I'll do this. So we have a real binomial and like a fake binomial. Like you don't need binomial theorem to expand 1 plus x to the 1. That's just 1 plus x. If you didn't write sigma notation, you just wrote 1 plus x, that's totally fine as well. You can just do it like that. But anyways, following our same steps so that we're all just doing the same structure, I now want n choose, or actually I told myself here, I want x to the r plus 1. I kind of broke a rule that I was telling you to do. What was the rule again? When writing this? Yeah, I should write the smallest one first, right? Look, I just want to show you can be flexible in math. So let's not follow that rule right now, but I'll show you where that can go wrong. You know how our first instinct is like, hey, let me take like the smallest power from here, and then I'll just get whatever power I need and I'll cycle through. Like I usually start with the smallest one so I don't miss any, right? What power of x do I want if I took an x0 here to get r plus 1? I need r plus 1, right? Do we have x to the r plus 1 from that second bracket? Obviously not. So that is why I was just giving you the advice that you could do it like that. 1 and n, and that way you won't run into the, whatever small power here will be covered by this bigger bracket. Fair? If you don't want to change your working, that's totally fine. I'm saying we're being flexible. Let's do it like this, and I'll show you what to do. You just go, okay, if I don't start from the smallest power, what's the other alternative? Should I probably start from the, I should start from the highest power? Yeah, the highest power of x I can get from here is n. Now that should be a good sign because look at what I want. Do you see why that's good? Because I want an n. Okay, what do I want from here to get r plus 1? Do I actually want r plus 1? Okay, you know what? I have just dug myself into 2 holes. Let me write down the 2 bad things you could do. Actually, it's both of these ones. That's bad. Do you see this one's also bad? Does that actually get you r plus 1? No. Okay, we're gonna have to think a little harder here. Are we okay with the 2 bad cases I've just written for you? What do I actually want? Now let's actually use our brains instead of following like a formula. Our brains tells us that to get that guy, or actually just in total, I want xr plus 1, yeah? Somehow I see n and r. The n here tells me I want to get an x power from this bracket, from the n bracket, and then the r here tells me what power I want. Does that make sense? This is which bracket is power n, and then this one is what power of x do I want. So do you see, this tells me I want the x to the r term from 1 plus x to the n. What does this term tell me? X to the power of what? That's what I want. Now we got our 2 pairs. Is that fair enough? Okay. Let's go back and write our two pairs. These are the bad cases. I don't want that. X, R was that first one I said for the first bracket. Okay, let's pray this works. I want x to the r plus 1. Is it possible to get an x term from this second bracket to get r plus 1? Yeah. What do I need? X to the power of what will make this x r plus 1? X to the power of 1. And that's actually good. All right. Let's think of one more pair. I've got x. I said I want x r plus 1 by looking at this. So, x r plus 1. What x term would I want from the second bracket? Was it? City? 0. Because it's already at r plus 1. Now, we know there are two pairs because there are two terms. We've done our job. Cool. Let's write our stuff down. N choose r. Then this one would be 1 choose 1. And then n choose r plus 1. 1 choose 0. We feel okay with that so far? Okay, great. Now, if you get a situation like this where it doesn't look like the thing on the right-hand side, just write equals next to each of those coefficients and write it like what they have. So clearly, 1 choose 1 is just 1. So you don't have to do much. You just go, that's equal to n choose r. If you want to explain, you can write times 1. And then n choose r plus 1 is just itself. Because 1 choose 0 is 1 as well. You can check that in your calculator. You could just say times 1. The rest of the question goes the same. Who can recite the conclusion? Since something, something, something. Since these two things are equal, that one and that one, we can, what's the technique called? Starts with an E. We can equate coefficients of x to the r plus 1. And then you just write the answer. Okay? So since n plus 1 equals n, 1, we can equate coefficients of x r plus 1, n plus 1, r plus 1. What did I get over there? We said n choose r times 1, which is n choose r, and n choose r plus 1. Are we okay with that? Okay. Now, that one, we went on a little bit of a journey, didn't we? Like, we made some, like, I made some mistakes on the board. Okay, two things to tell you. In maths, formulas slash, like, what's another word for a set of steps? I don't know, just a set of steps. Like, formulas and having a set of steps to do something in your head, that's good and it's bad. It's good because it makes questions really easy. Like, in HSC exam, you're just going to see the same questions popping up. This is just a hard question, but it's a common question type. So having those steps will just allow you to do it with accuracy. What's the bad thing about memorizing a set of steps? What did you see me do? Did you see me, you know that step? I was like, oh, we should write the smallest one first, and now avoid any issues. And I was like, we'll just start from x to the 0 all the time. Did you see that? That like me just copy and pasting? If I throw you a question like this where that step doesn't work, now all of a sudden you're like, oh, the step's not working. But here's what you do. It's important that you have a set of steps for certain questions. And when you get to one where it doesn't work, like you just saw, it is totally okay to fail on that first try. Try the thing you usually know, because that's how math questions work. Like you just apply things you already know and go, okay, it kind of worked, but not really. And then stop there, realize it doesn't work, and be able to adapt on the spot. What was that one too bad for adapting? It was a bit harder, but do you see I just used the same, like I just went back to here and I used our skill of, this tells me which bracket, this tells me what power of x. This tells me which bracket, this tells me x to the r plus 1. That's where I got r plus 1 from. Does that make sense, guys? Yeah. Okay, however, if I did follow my steps, I'm looking back at this, I think it would have worked actually. Like if I wrote 1 plus x to the 1 and 1 plus xn, and I just took x to the 1 and x0, I would actually just get it. Because I'm just looking for r plus 1. So it seems like I think our step would have worked anyway. But that's a lesson for, in terms of like, don't just follow it all the time. Yeah, be able to be adaptive. Okay. Any questions, guys? So far, so good. All right. Moving on. I will, when I have time, I'll rewrite that solution using my step. I'm just thinking, after that big lecture, my step actually works anyway. Okay, the next thing I want to prove is 1 minus x squared to the n. And it gives me those coefficients. Okay, now there are some questions in HSC, like this one, yes? That's so fine, it's recorded, and I'll just go a little bit faster to try to get as much on. Okay, it is recorded and we'll send it to you. Okay, so sometimes the questions are like much harder. Like you can see this one is just a different structure. We've been dealing with 1 plus x, right? What is 1 minus x squared? So do you see this one, they've scaffolded to give you hints, to not leave you in the dark and like make you sort of adapt to something you don't know. So there's also that aspect. Okay, so 1 minus x squared to the n equals 1 plus x to the n, 1 minus x to the n. Cool. Part A says, by expanding it in sigma notation. So let's do that first. 1 minus x squared to the n, we'll write that as sigma. Let me switch to blue pen. Sigma notation, so sum, n choose k, 1 n minus k, minus x squared, power of k. Let me just remind you that this is technically missing, starting from k equals 0, and we end at the highest possible bracket we can get, okay? Simplifying that, we get n choose k. The 1 is just 1, and then minus 1 to the k, x squared, k. Or x to the 2k. All right, so because we don't have our simple 1 plus x, and it's just slightly different, I'm doing that thing that Shobana was reminding us to do. Write in sigma notation, then what did Calvin tell you? You had to split it. How do we figure out how to split it? What two things am I splitting up? Sorry? Yeah, I'm like putting all the numbers on one side, all the constant coefficients, and I'm having all the x's away, yeah? That's why I'm taking out that x. So x squared would go there, and then the negative 1, I'd split that up so that I've got all my numbers here and then my x terms, all right? Okay, cool. From there, the question asks us to explain why the coefficient of x to the n is 0. Putting it in this notation is so helpful. I want the coefficient of x to the power of n. What should I do here to get x to the power of n? Any ideas? Guys, remember yesterday? You would get a question like this, right? I'm going to write the same one I wrote for you last time. I wrote something like this to the power of 10, and then you guys figured out that it should be something along the lines of 10 choose k. Let me chuck a 2 here, and then you're like, okay, take out the numbers, 2, and then you figured out, you know, it was like, I don't know, something like that. You know how you get this as that general term? Yeah. If I want the coefficient of like x to the 7, what are you going to do here? You're going to let that equal 7, yeah? If I want the coefficient of like x to the 10, you're just going to let this equal 10 and figure out what value of k you want, yeah? The question asks you for a coefficient of what? So what do you think I should do here? I'm going to say that in my working out. The question literally wants x to the n. So ready? For x to the power of n, let n equal, let that power 2k, the power of x, which I can see is that, equal n. All right, now this gets a bit confusing because yesterday it looked like 2k equals 10 and you could solve k equals 5. Now there are 2 letters, so you're unsure which one to like solve for. Just remember, I'm looking for k so I can plug it in here, all right? So now I'm gonna solve k equals n over 2. Now that should be red flags already, should be big warning signs. Why is that weird? Yeah, n's an odd number, and what about it? Good. So, did you guys do a question yesterday where it kind of blew up and k became like a fraction? I think I heard Calvin mention that. I don't know if you did a question on it, but Calvin mentioned that, right? K is what you're choosing from here. If I'm choosing stuff, I can only ever choose whole number of things. Like if I have 5 balls, I can't choose like half of them. Does that make sense? Okay, so it needs to be a whole number. It also can't be negative. That's another value of k you might get. And I can't choose -1 lots of something. So this must be, like this one, must be a positive integer or whole number. N over 2 looks like a fraction. It's not always a fraction. What types of numbers could the numerator equal that when you divide it by 2, you still get a whole number? Even. Is n even here? They literally told us n was odd. So I need you to not go like, oh, this is a fraction. I need you to explain that since n is odd, k equals n over 2, like both of them, is not an integer. Does that make sense, everybody? Beautiful. If there is no possible value of k, because this is like what k is it's all the possible terms you can get. Like every value of k represents a term. If there isn't a value of k that actually is valid, then there must not be a term in this expansion that results in power n. Does that make sense? So if there isn't a term there, then that term is just 0. It doesn't exist. Since k is not a valid solution, there is no term of x to the n. In other words, coefficient of x to the n is 0. I know there's a lot of writing here. I would simplify this a little bit just for an exam, but I'm just writing it so you have all the reasoning. Because I want you to realize that this is the first time you've seen it, and it's really important you understand the reasons of why this question works the way it does. Okay, part B is good. They kind of hand you what you want. You want the coefficient of x to the n, okay? So they tell you that. Now let's just do the same step we've been doing. So consider, who remembers the first statement? Who remembers the first bit? Consider the, what are we looking for? This topic is called equating coefficients. I'm looking for coefficients, right? So I'm going to look for, well, that's what consider means, coefficient of, the question tells me, x to the n. And then I don't just look for it from one thing, I look for it from two things. So I write this as like a little subtitle, and then I have step 1 and step 2. Step 1. The first one I look from is the kind of simple one before I split anything up. In this case, what would that bracket be? 1 minus x squared to the power of n. Good. We already wrote the sigma notation. So from part A, you already wrote it. I can just write the thing. This would occur when k equals, I want x to the n. Oh, okay. Sorry. From part A, you already know it's 0, right? So I didn't even put much working out there. I did all my working out here. Is that fair enough? Okay. Part A. From A. All right, step 2. With this one bracket, I'm turning it into 2 brackets, right? The way you look at what to split is you look at the identity. I can see my identity says n choose 0 squared minus n choose 1 squared plus the even one, even though it doesn't say, and then minus dot 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 plus, I think minus, n squared. Again, this looks different. The other ones, we had obvious pairs. Does this look like a pair to you? It's kind of like a secret pair, isn't it? What about it tells you it's a pair? It's a square. So do you see this is really n choose 0 and n choose 0? Yeah? Okay. So that's actually what the pair is. What would you split this up into? How would you split this up? N? Yeah. You would split it up as n. Okay. Now, here's how I would think about this. Or maybe we can push on that. Is this splittable as n? Like, isn't this just n? It's like, how can I take n and split it into like 2 n's? I can see clearly, like, I want something power n to get that first bracket, and I want something power n to get that second bracket. Do you guys agree with that? But like, this is a bit weird. So let's figure out how to split it. Because I only have power n. is there anything we can do to this to split it? Like other than just that? Yes? Good. Do you guys see 1 minus x squared is actually two basic ones combined together? 1 minus x squared is 1 minus x times 1 plus x. 1 minus x, 1 plus x. How do we see that? It's just the fact that I needed to split it, and I couldn't split it using the powers. Before I had power 9 that I could split into 3 and 6, but I already have the exact power I need. So I decided, yeah, let's try split from the actual factorization. Is that okay, guys? Again, sometimes you just think of this on the spot. Sometimes you have to be shown the first time. Like, you have to do it once before you can be like, oh, okay, I see this. So this feels hard because this is the first time you've seen this type of question. All right, now let's split it. I'm going to do my thingo. Let's write my sigma notation real quick. So don't be lazy here. There is a minus 1. Are we okay with the fact that I've got n choose k from that first guy, but then the 1 doesn't do anything, and it's the minus x to the k that's important here. So really, it's like minus 1 to the k, x to the k. Is that okay? Multiplied by, and usually I'd write it across, but I don't have enough space. Multiplied by n choose j, x to the j. Okay? Let's do our pairs. From this first bracket, what do you think I should get? They're both kind of equal in this case. I should probably get, look at this, see that n choose 0? Or you can work like this. I eventually just want x to the n, right? Just start from the smallest one again. Here, x to the 0. Figure out if you can actually get an appropriate one here. If this was x to the 0 and I want x to the n, what do I want this pair to be? N, yep. And then next one I'll go is x to the 1. I want this to be x to the, what would this power need to be so that it multiplies to become x to the n? Good. N minus 1. And then x squared, n minus 2. Convince yourself that when you add these together, you get n. Also ask yourself, can I actually get these, especially these sus ones, these are pretty big, can I get them from this? And the answer is yes, I've got n brackets here, so I can afford to get x to the n. Okay, that looks pretty good to me. Are we feeling okay with that? Do you agree it would just go like x cubed, n minus 3, and the pattern would just continue? I don't want to write all of them because I don't actually know how many there are. I don't know what n is. So let's stop at the last possible one. Where would this left-hand side go up to? What's the biggest one I could get? I've only got n brackets, so hopefully it ends at xn. And see if there's a corresponding one that works. Remember, I want this to multiply to become x to the n. Amy, what do you think? What should I multiply this by? I want this at the end to multiply to x to the n. Just like how this one, x1 and n minus 1, they become n, right? I just want n0, yeah. Okay, cool. Everyone okay with that? Vincent, all good? All right. Too many colors. I apologize for the squishy board work. I probably should have started a new question with this, but that's all right. Oh, I'm working with blue. Okay, now let's do it. I want x to the 0 from that first sigma, the one on top, yeah? That means k should equal 0. Sub in k equals 0. Do you see I get n choose 0 minus 1 to the power of 0? Anything to the power of 0 is just 1, so I really just have n choose 0. Then I want x to the n from that other sigma, the one on the bottom. So j should equal n choose n. Feeling okay with that? Todd, are you up to help me out? If you look at this one, that's x to the 1. I want the x1 term from that sigma, the first one. And choose 1. But also there's this guy. Did you write that part down? So this one is 1 minus x to the n, right? So do you see when I write the 3 brackets? Yeah, I have that extra minus, dude. Okay, so it's n choose 1 minus 1 to the power of 1, which is minus n1, and then n minus 1. Are we okay with that, guys? Yeah, and n minus 1 is just the second bracket. Let's keep going. X squared, x negative, or n minus 2. Okay. Sure. Oh my God. Sure. Is that right? Sure. Sure. X squared. From this one.
And choose 2.
Yep. Because minus 1 to the power of 2. Okay, guys? And then my next one is just like n choose n minus 2, right? Yeah. Positive n choose 2 and n minus 2. I'll just make it bigger. Make that more obvious. There's a minus. All right. And then skip to the n bit. Oh, this one's tricky. What about like this? Vincent, can I ask you to help me out with this one? So I want x to the n from this guy. Sick. What value of k do I want? I want n. So sub that in. What's the binomial coefficient? So obviously it's n choose n. But then, do you guys all see I have this minus 1 bit? It will be minus 1 to the power of n. What's that equal to? Because when it was minus 1 power 3, I can calculate minus 1 times minus 1 times minus 1. What about minus 1 to the power of n? You think it's minus 1? You think it's minus 1? Why is it minus 1? Good. That's all you do. You just use the fact that it's odd. So you saw that when it was like minus 1 cubed, you knew how to do that because 3 was an odd number. Minus 1 squared, positive, because even number. Odd is just minus 1. Okay? If you would like, 2 steps are working. Totally go minus 1 to the n, choose n, and then the other dude. Now the other dude's obvious, it's just n choose 0. Happy? All right, thanks for taking the time to go through that with me. Does this look like the thing we want to prove in the question? Damn. Let's compare each one and see how we can tweak this to turn into n choose 0 squared. This is n choose 0, that's n choose n. I want it to become n choose 0 squared. What would I love this second term to become? So that this is just a square. Yeah, because square means same thing multiplied by itself. N choose n. I would love that to become n choose 0. Who's done combinations here? Combinatorics? Some of you would know that that should actually be true, right? Think about this logically with me. If I have n things and I choose all of them, how many ways can I choose everything? I'm greedy. There's one way I can be greedy. Just one. Because I'm just taking all of it. I have no choice of which ones to take. Fair? If I have n things and I'm not greedy, I'm like, I don't want to take it. How many ways can I take it? There's actually one way to take nothing as well. Like, that is the way to not take anything. So do you see? There is one way to take all of it and one way to just leave it and not take it. They are equal. True? All right, help me out with this one. N choose 1 and n choose n minus 1. Now, can I put a number here? Like, for example, 3 and 3. Choose 2. If n is 3, then this is n choose 1, and then that's my like n minus 1, okay? 3 choose 1, I got 3 things, and I just choose one thing. Do you see there's 3 ways to do it? 3 choose 2, 3 things A, B, C. I could go A, B, and I'll take, no, sorry. Yeah, I could just take A, B, and leave C. I could take A and C, or I could leave A, and just go B, C. Do you agree there are 3 different ways to choose 2 objects out of 3 things? So do you see 3 and 3 are equal here? Does that make sense? If this is my n, and then that's my k, what would I write here? Yeah. If I have n things and I take k of them, that's the same as leaving n minus k of them. You can think of it like that. If I had 3 cars and I had to pick one of the cars, I could just go and, like the number of ways I could do that is I could choose the car I want. Or I could, out of elimination, eliminate 2 cars, and then I'm just left with the one I'm going to pick anyway. Do you agree that's the same? To choose in the team is kind of the same as choosing out of the team. That's what I'm saying here. this is an identity that I want you to remember, something to memorize. All good? Also, do you remember in Pascal's triangle, some numbers repeat? Like 1, 4, 6, 4, 1. That's why they repeat. The 4 and 4 are these two. Okay? Yeah, because you're about to leave, aren't you?
No, like just in general.
Let me finish the working out here, and then you can take the full one. This is horrible working out, so sorry. I hope you can read it. All right. What I would usually do is I'd write equals, and I really have to squish this. I'm so sorry, guys. I would then write equals n choose 0 squared, and then this one I'd write minus n choose 1 squared equals n choose 2 squared, and then equals minus n choose n squared. Like, I would literally just write what the question wants. And then I would justify why I did that. And the way I say that is I tell the marker the identity that I'm just recalling, that symmetry identity. So, since n choose k, n choose n minus k. So let me clarify one more time. We just did pairs, but our pairs didn't look like what they wanted. Their pairs were squares, right? That tells you that that last thing is equal to the first thing. So what you just write is you write what they want. You just show their squares. What's the reason behind why I can just turn it into this? Yes, because the symmetry tells me each one of these are the same. Is that all good? Notice also, I just made sure I wrote the minus there, even though it's very small and hard for you guys to see. Cool. I'm going to leave the conclusion because it's just the same. Like, since those guys are equal, you equate the coefficients of x to the n. Okay, you can take the photo. It's all done. Sorry, it's a bit hard to read. Okay. It always feels like this when you like get smashed with a question. Now, here's the thing with this holiday course. We have made it so that we finish off with combinatorial arguments, which is like a really hard thing, and it's not really, they ask it at the end of an exam in school. What I want you to take away from today is the first two, like the method of equating coefficients and substitution. I'm going to make this decision for us. If we get time, I'll show you a little bit of the combinatorial argument, which is like the word problem. But in general, I'm just going to focus on the thing that's most likely going to, like this will be in your exam, which is the first two sections. So is it okay if I put most of the time here and leave a little bit of the third one? Yeah? Okay. We've kind of been doing that across classes. Like when we felt like in a certain bit, we just skip some stuff. I know Calvin was very fast though, so let me try give you all of it. Okay. Let's go to, actually, do we feel horrible after doing that question? Does that feel really hard? Or was that manageable? Manageable? All right. Okay. Can I please get you try one last one? I'm going to give you 3 minutes to try it. And the question is this. It's the one on the other page, like the final example. I think it's like example 5 or something. It looks like this. Ready? N choose 0 squared. N choose 1 squared. N choose 2 squared. N choose n squared. And then it gives you some random factorial BS. In the HSC, they've asked this question before, and this is how they present it. I'm just going to write like that to make your life easier. I'm going to help you out with a little bit of it. Feel free to just start on it as well. Remember, the steps are the same, right? And also, can I just emphasize something? You know how this question it was a little bit harder because I made a mistake on the board? Are you guys cool with the fact that if I actually followed what I wanted, which is like, write the smaller one first, write the bigger one, then I could choose the x to the 0 term, I could choose the x to the 1 term, and then like life would just be great. It would just work out. Are you guys okay with that? So actually, I'd send my big lecture on like don't follow formula, but our method still works for this question, which is great. So follow our same method for this new harder question. But let me just walk you through slightly. Do you see the simple side? What does the simple side tell you again? What's that tell you? What's the 2n helpful for? The power of the expansion. So that would go here. Are we okay with that? What about that n? It's the x to the x to the x power, which is usually x to the k. So this is telling me I'm looking for the coefficient of x to the n from 1 plus x to the 2n. Are we all good with that? All right, I will let you write up the sigma notation and show me that this is 2n choose n. And then, can I get you to figure out the split you would want to get to here? And then you do the question. Sounds good? Give that a go, please. All right, guys. I walked around. Basically, sorry, I didn't see yours, Janelle, but I think Paul helped you out. This is basically your working out. Like you all got this. I saw it. It was beautiful. I'm missing something, and you guys wrote it. So help me out. I've just claimed that this is that. What should I justify it with? That identity. So what's my identity again? And choose a general number. So we go k is equal to what? Good. We okay with that? And then your conclusion is the same as usual. Happy days? All right. Now, a lot of you guys were asking me, wait a second, you made your question easier, didn't I? The question said, show that blah, 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 blah equals 2n factorial on n factorial, n factorial. Do we agree? Oh, actually, they didn't write that. They just said n factorial squared. You guys are so used to seeing the question as presented like this, and that makes your life easier, doesn't it? So if you're given this in the exam, your instinct should be, hey, what can I do to turn it into a binomial? Do you guys agree with that? Yeah? So let me try to show you how it is 2 and choose n. Okay. From yesterday's lesson, Calvin showed you a formula. What was the formula for combinations? Awesome. Instead of n, I'm just going to pick a different one, just because I can see n's here to avoid confusion. Let's call it t for like total brackets or something. Everyone's cool with that? Yeah? This is squared. Let me rewrite that as n factorial, n factorial. Do you see that looks more like two things multiplied together? All right, just matching from the top. What should be the total number there? It should be 2n, right? Awesome. And then that is now my k. Is that all right? I can see n here again, but what I was expecting was the total, the top minus bottom. Top minus k. 2n minus n. Do you see that's my n minus k term? Or my t minus k? So that tells me k is equal to n. And then, yeah, there's my top minus bottom. So that's where I wanted to get to. Is that okay, guys? Okay. Do we feel a little bit better? Can I emphasize? 99% of questions look like the first three I showed you with the numbers. 0.5% of questions now look like this one, where it's like n. And then like the hardest ones are the one, it's actually the fourth example I showed you. So I regret showing you that as the fourth one. I should have shown you that as the last one. That one where they give you hints and you have to like look for difference of squares. But that was just harder. But also, I know some of you actually found it not too bad. So pat on the back. And all of you were able to go through it. Go home and practice it. Sounds good? All right, moving on. I know we're crunch for time, but I have confidence that we will get through all of the main questions. Alrighty, we are now doing identities. Okay, guys, on this side of the board, you don't need my working out here anymore, right? Okay, on this side, I'm going to write down a subtitle called, I really don't need that much space, takeaways. When you're doing substitution, basically there is a different trick for each question, but I will show you how to identify what the trick is depending on what information they've given you, okay? So that is, at the end of the day, hopefully you've got tricks for like every single question. You're like, oh, okay, that's just this type of question. That's the technique, that's the technique. And they're all like really simple one-liner techniques, okay? So for example, this question, 1 mark. That's what's so good about this. 1 mark question. So you know it's gonna be short. All right, to do these questions, first of all, notice the difference is I don't have any pairs, right? If you see pairs, you equate coefficients. No pairs, you always, like basically every single time, you expand what I call the baby binomial, and that's this. 1 plus x to the n. So it's a baby binomial because his first term is 1, which makes all the powers of 1s are just great. They just disappear. So it is a very simple looking binomial. Now, you know how you guys are good at sigma notation? Can I please get you guys to expand this fully, like without sigma notation, because that's what these questions look like. It makes your life easier. So you just need to know how to do it once, and then every time it's the same. It's like this. Ready? N choose, or I'm going to write the sigma right here, and then I'll show you how it works. Are we okay with that? We've done this a billion times today. Okay, the first term is when k equals what? 0, okay? So that would be n choose 0, x to the power of 0. No x, because the 0 kills it. Then it goes up by 1, right? So now it's n choose 1, x to the power of 1. Cool? Now, I don't even need this anymore. The next one, you know, is 2, n choose 2, and then the x power always matches this guy. That's your k term. Fair enough? All right. What would be the next term? N choose x cubed. Amy, what would be the next term? X to the power of 4. It's just that, right? I don't need to write all those. Just write the first 3, ... N choose n. X to the, Todd, what's my last term? Good. Happy with that, guys? All right, starting with this, you just need to figure out what the hell we did from here to get to here. In fact, I baited you a little bit. This is the general binomial you have in harder questions with n. That's what you'd start with. Can you see there's probably a better one to start with here? Like, how does this turn into 80? N's just 80, right? So I don't have to write this first step. What you can do, if you wrote it, that's fine. You can just write this underneath. But in the exam, I would write it like so. 1 plus x to the 80, 80 choose 0, 80 choose 1, and so on. Eighty choose 80. So far, so good? Okay, great. Now, what did we do to go from here to there? Can you compare the pair, especially the longer side? Like there's only one side in the orange, so we'll just compare this. From the orange to the blue, or blue to orange, like what happened? What are we missing? There's no more x's, right? What is a value of x I can sub in here to delete it? 1. 1 will just kill off all the x's. So I want you to recognize that there's no x. So the step is you let x equals 1. That's what you substitute in. Remember, this topic is called substitution, so always just substitute a number in. 1 plus 1 is 2. So 2 to the power of 80 equals 80 choose 0, plus 80 choose 1, plus 80 choose 2, and so on, until 80 choose 80. Okay, so one scenario you see, the one scenario you see is when there are no x's, you let x equals 1. That's the first trick you learn. Cool. Here's the next one. Looks freaky, but I can see that the binomial should tell me what power to expand. Guys, I start with my baby binomial. It's usually 1 plus x to the n power. In this case, it's actually a number here. So can you guys see that would be n equals 10? N equals 10. Remember, the top of that binomial tells you how many brackets you're dealing with. 10 brackets. Can we expand this? What's the first term? Convince it. 10.
Isn't it?
Oh, you want to write the sigma?
No, it's n choose k,
Yes.
and then 1 to the power
10 minus k, and then x to the power of k. Because I'm dealing with k equals 0, 10 choose 0 first. Okay? And then x to the 0. So far, so good? Okay, cool. Do you help me with the next term? This is for k equals 1.
10 choose 1 times 1 to the power
But I don't care about 1, because it's just
x
1s.
to the power 1.
Good, like that. All good? Amy, what's the next term? Yep. Vincent, what's the last term?
10 choose 10.
Yep.
X to the power 10.
Good. Okay, that's what you start with first. All right, guys. The x's are clearly gone. I don't see any x's to go from there to there. But it's not like they just disappeared. What happened to them? It looks like it turned into 5. What do you think I should do as my step? Sub in x equals 5. I'll write the scenario over there. I think you get the idea. Let x equals 5. So here's a here's a lazy thing. You will find eventually, as you do more of these, you'll realize that it's nicer to write the long thing on the left side. So I'm just going to do a switcheroo here. So I'm going to write the long thing, but I'm going to sub in the 5. So 10 choose 0 plus 10 choose 1 times 5, which is just 5 lots of that, plus 5 squared, 10 choose 2, 5 to the 10, 10 choose 10. I'm just writing the right-hand side, but I'm writing on the left. Now that's going to be equal, whatever this left side is, okay? Someone tell me the value. What's it equal to? Like the exact value. You don't have to give me the actual number. What do you do? What do you do here? We solve x equals 5, so this must be, it's just 6. That's all you write. It's not that hard, okay? 6 to the power of 10. Just write that. Look at the question. Am I done? Is that what the question was asking? From the orange, I wanted this. Do I have what they're asking me? I'm just missing something. What am I missing? I don't want this guy because it doesn't start with 10 choose 0. Now, what's something I can do to both sides? I just minus them. And good. Here's the thing to realize, and I want you to actually write the answer as not just minus 10 choose 0, but minus 1. Because as you know, anything choose 0 is just equal to 1. Is that okay? I also want to put another thing in your heads. What would 10 choose 1 equal to? Like just in case you have to figure that out as well. 10 things, choose one of them. 10, that's equal to 10. So there are questions where this will now be like minus 10x because they've taken that one away as well. Is that all good? If 10 choose 1 equals 10, what's the other thing that I can choose that also equals 10? Good. So sometimes I might take away 20x because perhaps they, like, can you guys imagine this? Oh, no, not really. But I would take away like 2 because maybe I'd take away these guys, sort of. All right, you get the idea. It's okay. I'll just do this one for now. All good? All right, nice. So here's the next scenario. If you see increasing powers of a number, you just sub x equals the number, okay? See, we're building a bag of tricks. All right. Before you look at the title of that one, don't even look at this one. I know some of you have looked already. Just looking at this, I want you to, first of all, remember every one of these questions, you start with the baby binomial. So I start by expanding fully. 1 plus x to the n, okay? Janelle, can you help me write out this thing? 1 plus x to the n? Oh, sigma notation. Can you just give me the thing like expanded? Start with k equals 0, so n choose 0, and then n choose 1, x term? Yes, and then next one? I'm gonna write n choose 3 as well. Just for this one, I'm gonna write a little bit extra. You know how before I stopped at n choose 2x squared? Do you see this one, the question writes up to 3? I'll just write up to 3 so I have more to play with, all right? Guys, look at your orange, look at the blue. It's a bit misaligned right now, so you wanna be looking at it like that. N choose 1, okay, there's no x, cool. When there's no x, what do I do? When there's no x? Sub x equals 1. However, if I just sub x equals 1 in here, I won't get the 2 n choose 2. Do you guys see that? Huh. 3 n choose 3. This term, instead of just being n choose 3 by itself, there is a 3 out the front. And for this one with the x squared term, the x to the power of 2 term, there's a 2 out the front. With this x to the n power of n, x to the power of n is out the front. N's like kind of brought down. What happened here? What could possibly what could possibly do this? Wait, have you guys read the title? Oh, some of you haven't. Oh, sorry, I spoiled it for you. I should have said that. I'm really bad at doing stuff like this. Usually I go like, I'm about to ask you a question, but I'll tell you the answer before I even ask it. You're actually doing this in class? Okay. Oh, by the way, differentiation is not in the syllabus anymore. So if you're doing it at school, school's doing bad, Go ask the teacher, like, look at the syllabus. It says clearly, no substitute, no differentiation. Non-calculus binomial, that's what it says. But like, you can read it and ask your teacher. And then your teacher can just go like, oh, because you're smart, we're just doing it. The real reason is because it's in the Cambridge textbook. Anyways, differentiate. Do you see 2's gonna come down? Differentiate this, 3's gonna come down, n's gonna come down. That's where you get all the coefficients. Okay, I need you to please, everyone, like pay attention to this thing. This is really, really freaking important. Do not differentiate, do not sub in 1 and then diff. Always differentiate first. Why might I tell you to do that? Because if you sub in x equals 1, can you imagine these as n's or something? Can you differentiate this? Well, to differentiate stuff, you're doing respect to x. You need some x terms, right? Without x, all of these are just, aren't these just constants? Like, isn't that just equal to 1? You just differentiate a bunch of constants. And you know differentiating a constant equals 0. So your whole thing just dies off. So please differentiate first, then sub, okay? So in your exam, if you ignore my blue and green, you're gonna go here and you're gonna say, differentiate both sides. This means with respect to x. You're just saying what variable, because obviously there's other letters here. So I'm just trying to make sure I'm letting them know I'm not differentiating like n or something. Okay, be super careful here. I've got 1 plus x to the n. Remember we used chain rule to do this? You diff the outside, like the power, and then a little bit. Are we okay with that? And then you diff the inside. What's the diff of the inside here? 1. I still, like it doesn't really affect anything, but I still want you to write it. Okay, equals. N choose 0. What's the diff of n choose 0? What's the value of n choose 0? This is really 1 plus something, right? What happens when you differentiate constant? That guy just disappears. You don't have to write it. Happy? Okay, n choose 1. X just drops off. Remember diff of 2x is just 2? N choose 1. This one, the 2, it comes down. And the power lowers by 1, x to the power of 1. The 3 comes down. And then the power lowers by 1. And then the n comes down. And then the power lowers by 1. Are we okay with that? Cool. Okay. What do you think I need to do now? Yep. If I compare what I have with the orange, clearly there's no x. So let x equals 1. N times 2 to the n minus 1 equals n choose 1. 2, n choose 2. And n choose n. Okay, so you got that. If you have coefficients that are increasing, like instead of the coefficients all just being the same, like there's actually it's increasing, like 2 and 2, and then the next one increases to 3 and 3. I don't know a better way to describe this, but you get the idea. You want to diff, then sub. Never the other way around, but you want to diff, then sub. Are we okay with that? All right. Can I steal 3 minutes of your time? I just want to do one more question. Yeah, this will be the last one. Okay. And are you guys okay with just leaving off the third section? You can have a read of it at home. It's actually pretty self-explanatory. Okay, this guy's really important. So whenever you have, in fact, let me just give you like a general question. Can you guys write this general question instead? Because like this one's a little bit too funky. All right, ready? Show. 2n, choose. 0. No. 2n choose 1. 2n choose 2. 3. 2n choose 5. 2n choose 2n minus 1 equals half to the power of 4n. That look right? I think that looks right. Okay. Please write that question down for me. This one is meant to help you with example 9. It's basically the same. So you may like to, I can see there's a lot of space in example 8. So you might like to write it there. Or you can write an example 9 and do example 9 somewhere else. 2n, choose 2n minus 1. 2n minus 1. Sorry. Okay, now, there is something different on this question. But every single question, we start with one thing. What do we start with? Baby binomial, thank you. Now, in this baby binomial, do you see we started with 1 plus x to the 80, 1 plus x to the 10, 1 plus x to the n? How did I figure out this power? Because clearly that's the difference here. Well, I know this one's 80 because, can you see from the question? That says 80, right? What do you think I should start with here? 2n. Good. Let me not do random colors. Sorry, can you expand this for me? What should I start with?
2n choose 0.
Good. And then? Got y number? 2 and 1. Help me out.
X to the power 1.
Good. And then?
2 and 2, x
Yep.
to the power 2.
Give me one more.
2 and 3, x to the power 4.
Good. And then finish with 2n, choose 2n, x to the 2n. So far so good, guys? Same thing, but just 2n's. Okay. Now, look at the actual question. What is different about this one compared to all the other ones we've done? There is something different. 2n, 100%. I've already dealt with that. What else is different? Todd? Yeah, is that what you're going to say? Look, it's 1, 3, 5, 2n minus 1. Do you see we effectively have half of what we had before? That's also why we got like this half. So that's pretty cool. Okay, now, how the hell do you just get the odd ones? Here's what you do. You always, if you see, this is my scenario. If you see odd, you are going to, step 1, sub in x equals 1. Step 2, you're going to do something else. Step 3, you're going to do something else. So 3 steps for you. Ready? Let's do step 1 first. This is where I'm going to, again, I'm going to write the long side on the left, and you'll see that it's just a little bit helpful. Okay, so 2n choose 0, 2n choose 1, 2n choose 2, 2n choose 3, 2n choose 2n equals 2 to the 2n. This is step 1, but I should actually write, like I should tell the marker what I did. So let x equals 1. Now let me tell you the reason why I've been writing it like this. This is 2 to the 2n. Does that match what the question wants? Not really. What did they want? Half 4 to the n. But they want like a 4, right? Can I turn my thing into 4? What should I do? That's just 2 squared, n and power n. Do you see why it's so lazy? Like I wrote this on the left. If you wrote 2 to the 2n and then this, it's really awkward to go 2 to the 2n equals like some big freaking thing and then go, okay, that's 4n and not write the whole thing again. So do you see I'm just saving myself from writing the whole thing again? Yeah, lazy tactics. Okay. Step 2. There is something you have to let x equal to that will kill off a bunch of the terms. Now I'll give you a hint. It's not like x equals 5. Because do you see I don't have any like 5, 5 squared, 5 cubes. Like all the x's still disappeared. What's another number I can sub in for x that kind of just kills off all of the x's without leaving this kind of like, extra terms? -1. Do you see 1 killed off all the x's? -1 would do the same thing. It wouldn't leave off like, 2 cubed. It would just be -1 cubed. And it's almost like it was never subbed in. It's like all the x's were gone. Except, look, 2n choose 0. That's positive. 2n choose 1 times -1 is now negative 2n choose 1. True? And then 2n choose 2 minus 1 squared is equal to positive 2n choose 2, because that was an even power of -1. This is now an odd power of -1. It's -1 cubed, which means I should have minus. Are we okay with that? Usually a question in the exam, they actually just write it like this. So a scenario I should have wrote earlier is actually when you have alternating signs, you sub x equals -1. alternating flip-flop minus. Alternating plus minus, x equals -1. And then odd, we have our little step here. Okay, so step 1 is to x equals 1, step 2 is x equals -1. Let's go to the last bit. Guys, can you help me out? Would 2n choose 2n? Would that be positive or negative when I sub that in? How do you know that?
Because it's x to the power of even.
And how do you know it's even?
Oh wait,
Why is 2n even?
Anything that
Anything that
says
is even is a multiple of 2. Think about it. It is, right? So you can go if you need. Okay, so that guy must be -1 to an even power. That must be plus. So do you guys agree that is plus 2n choose 2n? All good? Now also, minus the last term, because the last term was a power 2n minus 1. An even number minus 1 must be odd. So do you agree that's minus as well? Part of the flip-floppy nature. Is that all good? All right. Isa, just before you go, do you know what I need to do here to get rid of all the odd terms? Oh, all the even terms? Yeah. Now, everyone, are you okay with that being 0? Because it's just like 1 plus -1, yeah? If I add these two equations right now, look carefully, what will cancel and what will stay? If I add it right now. 2n choose 0 plus 2n choose 0, do you see that doubles? What about this one? What about this one? And then cancels, right? Do you see all the odd terms cancel when you add it? You minus it. I think you need to go, sorry. Okay, call this equation 1. Well, I kind of did that here. Like, this is equation 1. And then call that equation 2. Guys, help me again. What am I doing with my equations? Am I doing 2 minus 1 or 1 minus 2? I'm going to do 1, take away 2. And the reason I do that is because I can minus these like negatives away. It's like double negative. So watch carefully. If I minus this, do you see the positive term minus positive term? They cancel. I don't write the even one. Now, 2n choose 1 minus -2n choose 1. Do you see that double negative will add them together? 2n choose 1. Are we okay with that? 2n choose 2, 2n choose 2. Did I cancel as well? Yes. Because it's just plus and plus and you're minusing them. What about 2n choose 3 minus negative of this? Do you see that doubles? That pattern continues all the way until that last odd term. Do you guys agree there's a missing 2n minus 1 term I haven't written? That odd term will double. The even term here will cancel. This even term will cancel, but there is an odd term here that will double. That is 4 to the n minus 0. Last step. And I can kind of just dodgily cross it out. Do you guys see what I need to do? Divide both sides by 2. Half. Okay. So step 3, for odd, you let x equals 1. Let x equals -1. And then step 3 is kind of dependent. If you have odd, you're probably doing equation 1 minus 2. And then if you have even, what do you guys think I need to do with these guys to make sure I keep the even and get rid of the odd? Or if I do that, it'll still be this minus that. Do you see that will still cancel? Plus, yeah. If I plus, this doubles and these cancel. Okay? 1 plus 2. Done. All right. Was that a bit of fun? It was okay? Now you have all these techniques. Go and take a photo of that takeaway thing. Here you go.